We'll start. Good afternoon. So in the last class, we were seeing about how the files, what are the operations we have done. That's what we have seen in the last class. We'll just have a look and go back. So we have started with directory structure, and in directory structure, we have so many operations what we can do on a directory structure. Search for a required file, create a file, delete a file, list a directory, rename a file, traverse the file system. And single level directory where we are keeping all our data only in one single thing. That's what single directory. And two level directory where we do user one, two, we keep one folder within that one more folder. That's all. That is what is called as a two level directory. That this is what the picture what we have seen for a two level directory structure. So then this is a tree structured directory where there is a tree form. This is what the tree form is, where you see what are the tree. You may have a one file within one more file, one file within one more file, one file within one more file. So that's what is called as a tree structure. And we have seen, and even nowadays also you would have seen so many examples where you create a folder saying that second semester. In that you may create so many folders. One may be your operating system, one may be Java folder, one may be CN folder. Like that you may create. Again in operating system, you may create one more file, one more folder called as a notes, OS notes, and one more you may create OS PPTs, and one more you may create OS assignment. One more you can create one more thing. Like that you may create so many folders. That's what is called as a tree structure. And we have seen about a cyclic graph where the files can be shared between so many number of people. Then file mounting also we have seen in the last class. Then file sharing. So if the same project is being done by so many people and it should be shared among same the project work has to be shared, then we use this file sharing concept. And remote filing system, the best example what we are doing right now is a online classes. So what we are doing, we are sharing these PPT files. That's what we have a share the files and we start recording and we upload in YouTube. So this all these whatever we are doing, that's what is called a remote file system. Then we know about protection. Even you can see even in Arogya Setu app also there is a protection. Though we know that within 500 meters there is some person positive and it shows that it is a risk, but still it is not saying which person who is affected. Still the information is hidden. So same way here, protection. So everything. So our personal details should be protected. So that's what here we say protection. And what are the type of access we can do? So that's what read, write, execute, append, delete, and a list. So that's what here these are the types of access. And access control, usually protection is achieved by controlling file access depending on the identity of the user. So various users may need different types of access to a file or a directory. Hence, an access control list, that's what ACL. So how do we control that? That's what we have seen in the access control thing. And we have seen about the owner, group, and the universe. This is what we have seen in the last class. Now we start with the file system structure. So what is this file system structure? So now take an example. You are writing, take any problem, and first what you'll write a algorithm. So what is algorithm? It is a step-by-step procedure to solve any problem. So when we have algorithm, why do you write again a flow chart? Why do we require a flow chart? So to make the problem understand easily, or the human can the human being can understand better with a picture rather than a text. So algorithm is a text format. Flowchart is a picture format. That's the reason we use a flowchart. Not only flowcharts, in the programming, there are so many other pictured form things where one is flowchart, one is data flow diagrams, which you would have seen in a DBMS, and we will be studying in some more further semesters. One is UML diagram. So what is this UML diagram? Unified Modeling Language. Based on that, we use so many structures or diagrammatic. Same way here, file system structure. What is this is doing? Disks are provide the bulk of secondary storage on which a file system is maintained. So now when you purchase a laptop, you see how much hard disk space we have. Yes, so that's what here file system structure is also is been doing, on which a file system is maintained. So they have two characteristics which will help for convenient storage of multiple files. So they can be rewritten in a place. It is uh, it is possible to read a block from the disk, to modify the block and to write it back into the same place. So that's what here we are doing a file system structure. And one more, they can access directly any given block of information on the disk. So that's what here file system structure. This is what we are doing in the file system structure. That's what you can see here. This shows us a layered file system. So to provide an efficient and convenient access to the disk. So how should we, suppose you think that you have downloaded one module, four operating system module from your net, and it is there somewhere and you are not able to search. Then what you will do? We have an option called as a search, and you say you give the name there, and automatically the system will be searching. Same way here. So it will be difficult if you keep everything somewhere and you keep searching somewhere. So the operating system imposes one or more file system to allow the data to be stored, located and retrieved easily. The file system is composed of many different levels. The figure 4.8, what it shows is an example of a layered design. Each level in the design uses the feature of lower level to create new features for use by higher level. So you can see here the application program, logical file system, file organizing module, a basic file system, input output control device. So this is what how the layered file system is keep going. First one is a lowest level input output control consists of device drivers and interrupt handler to transfer information between the main memory and the disk drive. So what we do here, how the main memory and how the lower level architecture is being done. So the basic file system needs only to issue generic commands to the appropriate device drivers to read and write a physical block on the disk. So you would have known that if you want to use some special instruments or special part in your laptop, then even related software or device driver should be low installed in your either a laptop. So let us take your example of in your mobile. So how many apps we are using? If you want to use any banking application, then related banking application or app should be downloaded. That's what your device drivers. So related to that we require. So the file organization module knows about files and their logical blocks as well as physical blocks. The logical file system manages metadata information. So how we can do it with the file organization. Next we move on. How do we implement a file system implementation? Several on disk in the memory structure are used to implement a file system. These vary depending on the operating system and the file system, but some general principles are common for all the operating systems. On disk, the file system may contain information about how to boot an OS stored there, the total number of blocks, the number and the location of the free blocks, the directory structure and individual files. The on-disk structure includes boot control block. That's what once you start your laptop, you should click on a power button. So when you click on a power button, what it is happening automatically, whatever is there in your hard disk will be loaded to your RAM. With what will be loaded, which are required. That is operating system will be loaded. That's what is called as a boot control block. Can contain information needed by the operating system to boot from that partition. If the disk does not contain an OS, this block can be empty. It is typically the first block of the partition. So what we do here, that's what for anything when you want to use your laptops, your operating system is compulsory. It may be any operating system, either it may be disk operating system or Windows or any either Unix operating system, any operating system you can use. So whenever you are using, it should be booted. Where it should boot, it will be present in your hard disk. If you want to on your laptop, then it should come to a RAM. So that's what here, that whatever we are taking from a hard disk to the RAM, that's what is called as a boot. A partition control block contains partition details such as the number of blocks in the partition, size of the block, free block count and free block pointer, and free uh, file control block. So and FCB pointer. A directory structure is used to organize the files. So that's what, how do we do? We keep our directory structure. So what is directory structure? That's what I told you, your second semester MCA. Again in second semester MCA, you may create so many folders. One folder for each subject. One folder or one directory, we may call it as operating system. One may be DBMS, no, DS. One may be your DMS. One may be your network. One may be Java. So then what we have done, your main directory is second semester. Within that you have created so many directories. And again within that, if operating system, within that also you can create so many. One for notes, one for PPT, one for assignment. So what we are doing, directory structure. That's what you can organize all your files. And FCB contains many of the file details, including file permission, ownership, size, and location of data blocks. So in the in-memory information is used for both file system management and performance improvement via caching. The structure can include an in-memory partition table containing information about each mounted partition, and in-memory directory structure that holds the directory information of recently accessed directories. The system-wide open file table contains a copy of the FCB of each open file as well as another information. The per process open file table contains a pointer to the appropriate entry in the system wide open file table as well as other information. And a typical file control block is shown in the figure. So you can see here how this file control block is there. First is file permission, file data, dates, create, access and write. So file owner, group or ACL. Then file size, file data block. So this is what here is required for a typical file control block, FCB. So then you can see in this diagram, in-memory file system and a file open and a file read. The first one, user space. So when we open, we are being given with small temporary memory. That's what is called as a user space. Directory structure, that's what I just told. Your second semester is top directory. Again, within that there may be so many directory structure. So that's what they, where it will be done. It will be done in a kernel memory. And after that, you're storing all your directories in a secondary storage. What do we mean by secondary storage? Secondary storage is nothing but your disk. So again, in disk you may create directory structure. You may create any number of directories, and we have something called as a file control block. Same way here, you can see user space, kernel memory, and a secondary storage. So that's what here, index, feed process, open file table. All these are an example for in-memory file system structure. Next one, directory implementation. So how do we do this directory implementation? The selection of directory allocation and directory management algorithm has a large effect on the efficiency, performance, and reliability of the file system. So directory, how do we implement this? We just say, I just create file new and this, but how should be done with respect to the implementation? So now we move on a linear list. Linear means what? One after the other. So after Ashok, Chaitra, after Chaitra, some other person, after Chaitra, Bhavisha, like this one after the other, one by one. That's what is called as a linear list. The simplest method of implementing a directory is to use a linear list of file names with pointer to the data block. A linear list of directory entries inquiry requires a linear search to find a particular entry. This method is simple to program but time consuming to execute. So to create a new file, we must first search the directory to be sure that no existing file has the same name. Then we add a new entry at the end of the directory. To delete a file, we search the directory for the named file, then release the space allocated to it. So to reuse the directory entry, we can do some of the several things. Make the entry as unused by assigning it a special name such as all blank names or with used unused bit in each entry. Attach it to a list of free directory entries. Copy the last entry in the directory into a free location and to decrease the length of the directory. And one more option, linked list. So what we do, linked list is used to decrease the time to delete a file. The real advantage of linear list of directory entries is a linear search to find a file. Directory information is used frequently and user would notice a slow implementation to access it. That's what about the directory structure. Next we move on to a hash table. So hash table, another data structure. So now you have so many data structure. What is primary? If I ask you what is uh, mm, preliminary data structure and non-primitive data structure. Primitive data structure means integer, string, all this. Non-primitive data structure, what we you call as a trees, uh, all whatever you are seeing in your data structure, like linked list, double linked list, circular queue, all these are a non-primitive data structure. Same way here, hash table, it is another data structure that has been used for file directories in the hash table. In this method, a linear list stores the directory entries, but a hash table, hash data structure is also used. The hash table takes a value computed from the file name and returns a pointer to the file name in the linear list. Therefore, it can greatly decrease the directory search time. Insertion and deletion are also straightforward. Although some provision must be made for collision situations where two file names hash to the same location. The major difficulty with the hash tables are in general fixed size and depends on the hash function on that size. So can we create any folder with the having the same name with the two folders? No, it is not possible. At least one letter or one character should be different. So that's what here. Even in the hash table, though we can create a fixed size, but again it depends upon how we function of the hash and its size. So then next we move on to the allocation method. So how should I allocate? So how did you PBL? That's what your mini project allocation has been done. You people only started grouping among yourself, and you come up, you and your friend, you you came up and you told that we both will be doing the project. Same way here in the allocation method, what we are doing is how should I allocate the memory space for anything to be stored? That's what here direct access nature of a disk allows us flexibility in the implementation of files. In almost every case, many files will be stored on the same disk. The main problem is how to allocate space to these files so that disk space is utilized effectively and files can be accessed quickly. Three major methods of allocating disk space are continuous, linked, and indexed. That's what how do we do a major allocation method. First one is continuous allocation. So in a continuous allocation, files are assigned to a continuous area of secondary storage. So a user specify in advance the size of the area needed to hold a file to be created. So suppose you think that in your class, how many students are there? 53, 55 students are there. Then if I want to take a class physically in our college, then what I have to do? I have to have a place where I can see all 55 chairs are available. Then only I can ask you people to sit. Same way here also in a secondary storage device, what we do is a user specify in advance the size of the area needed to hold a file to be created. If the desired amount of continuous space is not available, a file cannot be created. A continuous allocation of disk space is shown in the figure. So that's what here in continuous allocation, what we do, you can see here, 0, 1 is full. The color, we have a color there. 0 and 1 is filled. 6 and 7 is already filled. 14, 15, 16 is filled. 19 to 24 it is filled. 28, 29, 30, 31 is filled. The free spaces you can see 2, 3, 4, 5 is free. 8, 9, 10, 11 is free. Like this we can see what is filled and what is unfilled. And we have given a name also. What is the file name for 0, 1? Count. And where it is started? 0. What is the length? 2. So in the same way, TR. What is the TR? It's a name given for the allocation of the file. So from where it is started from a 14. And where what is the length? 14, 15, and 16. That's what the 3 length. So one more file name mail. So from where it is started? It is started from 19 to 24. So what is the size? 19, 20, 21, 22, 23, 24. How many we have? 6. Length of that mail is 6. Means blocks. How many blocks are there in mail? 6. One more file with a name list. So where it is started? Started from 28. So how many are there? 4. So 1, 2, 3, 4. So then what is F? F is also one file where it starts from 6 and ends length is 2. So that's what here. This is continuous allocation of a disk space. In a continuous allocation, files are assigned to continuous area of a secondary storage. A user specify in advance the size of the area needed to hold a file to be created. If the desired amount of continuous space is not available, the file cannot be created. A continuous allocation of disk space is shown in the figure 4.11. One advantage of continuous allocation is to have a successive record of the file are normally physically adjacent to each other. This increases the accessing speed of the record. So why do we say that you only group and you only do your projects, mini projects? Because you and your friend are uh, friendly. Means you both of you can understand both your problems and you can solve. That's the reason we left you free. Same way here, even in a continuous memory, continuous means one after the other, the space will be free so that we can keep the information. So that's what here. It means if the record are scattered through the disk, it is accessible with a slower. Suppose if free space is here and one more free space is somewhere after two lines. After fourth line or fifth line, one more space is free. Then it will be difficult for us to store small information here, small information there, another small information somewhere. So that's what here it will be scattered. For sequential access, the file system remembers the disk address of the last block and when necessary, read the next block. For directory access to the block B of the file that starts at the location L, we can immediately access block L plus B. Does the continuous allocation support both sequential and direct access? So the disadvantage of this is the disadvantage of continuous allocation algorithm is it suffers from external fragmentation. As files are allocated and deleted, the free disk space is broken into little pieces depending on the total amount of disk storage and the average file size. External fragmentation may be a minor and a major problem. That's what about sequential. Sequential means one after the other, one after the other. If my free memory is continuous, then only I will store. If it is broken, if some part is here, some part is there, some part is there, that is what is called as a continuous. One more is a linked allocation. So linked allocation, suppose some memory is free here, some memory is free there, some memory is free there. So then what I do, I have a link of all these. So that's what is called as a linked allocation. So linked allocation solves all problems of continuous allocation. With linked allocation, each file is linked of a disk block. The disk block may be scattered anywhere on the disk. The directory contains a pointer to the first and the last block of the file as shown in the figure. You can see there is one file called as a Jeep. Where it started at 9 and it is ended at 25. And there are links there. So 9, and from 9 it goes to 16. 16 it goes to 10. From 10 it goes to 25. 25 it goes to 25. Again it goes to 25. 10 to 25. That's how here the link is there, where it started, where it is ended. There will be a link between all these wherever the free space is available. That's what is called as a linked allocation. So linked allocation solves the problem of external fragmentation, which was present in continuous allocation, but still it has a disadvantage. Though can be effectively used for sequential access files, to find ith file, we need to start from the first location. That is, random access is not possible. That was the linked allocation. Next we see about a indexed allocation. So indexed allocation means, if example for indexed allocation is your textbooks. How is your textbook? We have an index in the first two or three, after 2 or 3 pages. You can directly go to that particular chapter by seeing the page number. So suppose if I say fifth chapter starts at 20, I can go to a directly to a 20th page to see the fifth chapter. That's what here indexed allocation. This method allows direct access of files and hence solves the problem faced in linked allocation. Each file has its own index block, which is an array of disk block address. The ith entry in the index block points to the ith block of the file. The directory contains the address of the index block as shown in the figure 4.13. So you can see there is an index block saying 19. From 19 is an index. So 19, from 19 you can go for 9, you can go for 16, you can go for 1, you can go for 10, you can go for 25, minus 1. Like this you can go. This is what is called as an index. One storage, we call it as an index. From that index you can traverse, move from one block to the another block. Then free space management. Since disk space is limited, we need to reuse the space from a deleted files for a new files if possible. To keep track of free disk space, the system maintains a free space list. The free space list records all free disk blocks, those not allocated to some file or directory. To create a file, we search the free space list for the required amount of space and allocate that space to the new file. This space is then moved from the free space list. When a file is deleted, its disk space is added to the free space list. A free space management is done using different techniques as explained here. You can see here, this is what is called as a bit vector. What do we mean by bit? So bit means either you may say 1, 0 or 1. Suppose let me take an example of fan. So what is an option for a fan? Either it can be in a on state or in the off state. So that's what is called either 0, 0 or 1. That's what here, same way here, bit vector. Bit vector means like this I may have any 0, 1, 0, 1, 1, 0, something like that. That's what is called as a bit vector. So frequently a free space list is implemented as a bitmap or a bit vector. So how should I know that this memory is free, this memory is free, this memory is free? So this will be done by a bit vector. Each block is represented by one bit. If the block is free, the bit is 1. If the block is allocated, the bit is 0. Means what? How should I know that the memory is full or memory is free? If the bit block, if I have a block, within that block, if there will be one bit called as a bit block. If it is 1 or 0, based on 1 or 0, we can say whether the memory is free or not. For example, consider a disk where the blocks 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, like this. I have so many blocks which are free and rest of the blocks are allocated. The free space bit map would be, so 2 is what? 0, 1, yes, 2. So when do I get, so wherever you can see in this sequence, if the block is free, the bit is 1. If the block is allocated, the bit is 0. It means what? So 0, 1. Wherever you have 0 means what? It already memory is full. Wherever you have 1 means what? That particular block is free. That's what you can see in this sequence. 0 is allocated, 1 is allocated, 2 space free, 3 space free, 4 space free, 5, 5th place free. Wherever you have 1 means what? The blocks are free. That's what here you can see. This is what a bit vector. So what does this says to us? Which part of memory is free, which part of memory is full. This technique is simple and efficient in finding the first free block or n consecutive free blocks on the disk. But bit vectors are inefficient unless the entire vector is kept in the main memory. Keeping it in the main memory, it possible for a smaller disk, such as an microcomputer, but not for a large ones. This can be done, this can be implemented only for a small part of the memory. So one more, we have something called as a linked list. What is this linked list? Another approach for free space management is a link together all free space blocks. Keep the pointer to the first free block in a special location on the disk and catching it in the memory. This first block contains a pointer to the next free disk blocks and so on. However, this scheme is not efficient. To traverse the list, we must read each block, which requires substantial input-output time. Fortunately, traversing the free list is not a frequent action. Usually, the OS simply needs a free block so that it can allocate that block to a file. So the first block in the free list is used. Next one, grouping. So what we do? A modification of a free list approach is to store the address of n free blocks in the first free block. The first n minus 1 of these blocks are actually free. The last block contains the address of another free block and so on. The importance of this implementation is that the address of the large number of free blocks can be found quickly, unlike in a standard linked list approach. The counting, another approach is to keep the address of the first free blocks and number n of a free continuous blocks and then the first block. Each entry in the free space list then consist of disk address and the count. Next one is a disk structure. So how is our hard disk structure? Disk provides a bulk of secondary storage for modern computer system. Magnetic tape was used as an early secondary storage medium, but the access time is much slower than for the disk. Modern disk drivers are addressed as large one-dimensional array of a logical blocks, whereas the logical block is a smallest unit of transfer. The size of logical block is usually 512 bytes, although some disks can be low-level formatted to choose a different logical block size, such as 1024 bytes. The one-dimensional array of logical blocks is mapped onto a secondary sector of disk sequentially. Sector 0 is the first sector of a first track on an outermost cylinder. The mapping proceeds in order through that track, then through the rest of the track in that cylinder, and then through the rest of the cylinder from the outermost to the innermost. So what we do here, so your disk, your memory is something like this, and it will be divided where we call it as a sectors. So next we move on to a disk set scheduling. So what do we mean by disk scheduling? One of the response, what we have seen in a CPU scheduling. So what is CPU scheduling? You see to that your processor should be not free. You should keep making your processor to work. So in the same way here, in a disk scheduling, what we do, how this disks are been, uh, how the hard disk have to schedule. One of the responsibility of the operating system is to use a hardware efficiently. I have to use my hardware efficiently. This will help in achieving fast access time and a disk bandwidth. The access time has two major components. The one, seek time, is the time for a disk arm to move the head to the cylinder containing the desired sector. The rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. The disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. We can improve both the access time and the bandwidth by scheduling a servicing of a disk input output request in a good order. So whenever a process needs input output or from the disk, it issues a system call to the operating system. The request specifies several pieces of information, whether this operation is input or output, what the disk address for the transfer is, what the memory address for the transfer is, what the number of bytes to be transferred is. So all these information will be taken when we have a request. If the desired disk driver control are available, the request can be served immediately. Suppose you think that when you go for a hotel and you ask for a idli vada, if it is available, then very soon they'll serve you. If it is not available, now take your gobi. So what you have to do, you have to wait for 15 minutes because gobi should be prepared for you and served. That's what your similar way. If it is available, it will be given served very immediately. If not, if the driver or a controller is busy, any new request for a service will be placed on a queue of pending requests for that drive. For a multi-programming system with many processors, the disk queue may often have several pending requests. Thus, when one request is completed, the operating system chooses which pending request to service the next. First one you can see, first come first serve scheduling. What do we know about first come first serve? The same example. Who are in the first queue to take a darshan for temple in a temple, that person will be first to come out. Same way here, first come first serve scheduling. The simplest form of disk scheduling is, of course, the first come first serve algorithm. This algorithm is intrinsically fair, but it generally does not provide the fastest service. Example, consider a disk queue with request for input output to block on the cylinders 98, 183, something like that in that order. There are 200 cylindered numbered for from 0 to 199. The disk head is initially at the cylinder 53. Then how do we compute the head movement? Computing the cylinder start with 53. It will first move from 50 to 53 to 98. Then to 83, then 37. Like this, it keeps going. So that's what here you can see. Head movement from 53 to 98 is what? How many total blocks? 45. 80, 98 to 183, 85. Then 83 to 37, 40, 146. So 37 to 150. Like this, it keeps going from one block to another block. And the total movement, how many are there? Total movement 640. You can see with the diagrammatic representation how this first come first serve scheduling will be done. I'll stop here and we'll continue in the Saturday's class. So I'll try to complete in the next Saturday class this module 4. Then we'll start with module 5 in the next week. So now let us have a revision, have a look what we have covered today. So we have started with a directory structure. So what is the file system structure? So what is a how is a file system structure? And we have seen how this layered file system are. Then we have moved on file system implementation. How do we implement? Then we have seen about a file control block. How we have a PCB process control block. Same way here we have something called as a file control block. How do the files are controlled? So we should have a permission, we should have a dates, we should have a owner, we should have a size and the data blocks. You can see all these. This is what the how the in-memory files opens and the reads. Then we have seen about a directory implementation. How do we implement the directories? How to create, how to delete, how we can use all the implementations for the directory. And we have seen about a hash table. So same way how we have a linear list, how we are doing. That's what here a hash table. Then allocation method. How do I allocate my memory? So one is continuous, one is indexed, and one was linked list. So continuous means wherever continuously is available memory, then only it can fix. If it is not continuous, then I am leaving like that only. That's what the concept of continuous allocation. And linked allocation, wherever small memory is also free, I try to link wherever small. It is not required to be continuous. It can be differently, but I can link all this. So that's what is called as a linked allocation. And last one we have seen about the indexed allocation. Indexed allocation similar like your textbooks, where you have an index page. You can go from indexed page to any chapters. That's what your indexed page. And we have seen how do we manage the free space. One is using the bit vector, one is using a linked list, and one more using a grouping and counting. These are the four methods where we can keep track of our free space. Next is disk structure. How is our hard disk? How it is structured? How it is? So everything in the modern computer we keep in a form of a blocks. So how do we schedule all these blocks? And in that case, we require some major components. One is seek time, rotational latency, and a bandwidth. So then we have seen about the first come, first serve scheduling. And we'll stop and we'll continue in the next class.